Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 12. Now the first thing I'm going to do is I'm going to take the log on both sides. So I have log 6 to the power of x is equal to log 12. Now, an important property of logarithms is that, let's say I have log a to the power of b. I can actually move this exponent b to the front of the logarithm. So this is going to be equal to b times log a. So now for log 6 to the power of x is equal to log 12. For log 6 to the power of x, we can think of a as 6 and b as x. So if we want to change it into the form b to the power of b times log a, I'm going to move this exponent x to the front of the logarithm. So now this will be equal to x times log 6 is equal to log 12. Now I can divide both sides by log 6. So then these two cancel out, and I would have x is equal to log 12 over log 6. Now, log 12, this is the same thing as log 6 times 2. And for logarithms, an important property is that if we have something in the form log a times b, this is equal to log a plus log b. And the same obviously applies vice versa. So for x is equal to log 6 times 2, log 6 times 2 would be equal to log 6 plus log 2. And we're dividing this by log 6. So now we can rewrite this as log 6, over log 6 plus log 2 over log 6. So for log 6 over log 6, those two cancel out, so that would equal 1 plus log 2 over log 6. Now, log 6, I can rewrite as log 2 times 3. And remember, if we have something in the form log a times b, this is equal to log a plus log b. So that we have x plus 1 plus log 2 over log 2 times 3. This would equal log 2 plus log 3. So I have log 2 plus log 3. Now, the value of log 2, if you plug this into a calculator, it is approximately 0.301. And the value of log 3, if you plug into a calculator, it is approximately 0.4771. So we have x equals 1 plus log 2, which is 0.301, over log 2 plus log 3. So 0.301 plus 0.4771. So now I have x is equal to 1 plus 0.301 over 0.301 plus 0.4771 is 0.7781. Now 0.301 over 0.7781 is 0.3868. And finally, 1 plus 0.3868 is 1.3868. So this is our answer. So we have 9 to the power of x is equal to 18. Now, the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 9 to the power of x is equal to log 18. Now, an important property of logarithms is that, let's say we have something in the form log a to the power of b. We can actually move this exponent b to the front of the logarithm. So this is going to actually equal b times log a. So I'm going to use this property on log 9 to the power of x. So we can think of 9 as a and x as b. So I'm going to move our x here to the front of the logarithm. So this is going to equal x times log a. So now I have x times log a is equal to, sorry, it's not a, it's 9. So I have x times log 9 is equal to log 18. Now we want to isolate x, obviously. So I'm going to go ahead and divide log 9 on both sides. So now I have x is equal to, because these two cancel out, log 18 over log 9. Now 18 is equal to 9 times 2. So I'm going to rewrite log 18 as log 9 times 2. And now we're dividing this by log 9. So now, if I have a logarithm in the form log a times b, this is actually equal to log a plus log b. Because remember, if you guys already didn't know, when you're adding logarithms, you're technically just multiplying the two numbers in front of the logarithms. So now log 9 times 2, this is going to equal log 9 plus log 2. So now I have log 9 plus log 2 divided by log 9. And now this is the same thing as log 9 over log 9 plus log 2 over log 9. All I simply did was I divided this into two parts, because remember, if you add these again, you'll simply get log 9 plus log 2 over log 9. So now, log 9 over log 9, these two would cancel out, so this is the same thing as 1. So I have 1 plus log 2 over log 9. Now, log 9, well, 9 is the same thing as 3 squared. So now if I replace 3 squared for 9, I get x is equal to 1 plus log 2 over log 3 squared. Now remember, property of logarithms, that states that if we have something in the form log a to the power of b, we can move our exponent b to the front of the logarithm, so this would equal b times log a. So log 3 squared So in this video, I'm going to solve the problem 2 to the power of 19 minus 2 to the power of 18. So I want to find the value of this problem. So for my solution, I'm going to start by rewriting my problem here. So 2 to the power of 19 minus 2 to the power of 18. And to start off, I'm going to rewrite 19 here as 18 plus 1. So I get 2 to the power of 18 plus 1 minus 2 to the power of 18. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1 is equal to 2 to the power of 18 times 2 to the power of 1. And now I have this minus 2 to the power of 18. Now from here, because I have two terms that are the same, I can factor out 2 to the power of 18. So I get 2 to the power of 18 times, well, 2 to the power of 18 times 2 to the power of 1 divided by 2 to the power of 18 is simply just 2 to the power of 1, and negative 2 to the power of 18 divided by 2 to the power of 18 is negative 1. So I get 2 to the power of 18 times 2 to the power of 1 minus 1. And this is equal to 2 to the power of 18 times, well, 2 to the power of 1 is 2, so I get 2 minus 1, which is equal to 2 to the power of 18 times 1, which is equal to 2 to the power of 18. So I get 2 to the power of 18 as my answer. Now, there is actually another method of solving this problem. So going back, our original problem was 2 to the power of 19 minus 2 to the power of 18, right? And what we did was we wrote 19 as 18 plus 1, and we solved it by factoring out 2 to the power of 18. So now, what if instead of rewriting 19, I rewrite 2 to the power of 18 as 2 to the power of 19 minus 1. Now, the way I'm going to solve this is I'm going to rewrite 19 minus 1 as 19 plus negative 1. Now, I can still use that property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 19 plus negative 1, that's going to equal 2 to the power of 19 times 2 to the power of negative 1. So I can still do it. Now from here, my greatest common factor from these two terms is 2 to the power of 19. So I get 2 to the power of 19 times 1 minus 2 to the power of negative 1, which is equal to 2 to the power of 19 times 1 minus 1 half, which is equal to 2 to the power of 19 times 1 half, which is equal to 2 to the power of 19 times 2 to the power of negative 1. And 2 to the power of 19 times 2 to the power of negative 1 is equal to 2 to the power of 18.